Okay,
Sorry, go.
cool. So what I would love to do in this session today, and I love that CV that we have practitioners here in the room, um, to have more of a discussion than just a presentation. I'm going to present a couple of things, but I would love to have a deeper discussion. And I want to bring up a topic, which I've been talking for 3 years, been waiting. Yeah,
Okay.
kind of, he knows, okay, in which direction it goes. And today I'm going to complain about academia. And I want to talk about especially the challenges of advanced analytics in industry, right? And I'm gonna give you a little bit of a background and why I am talking about it. And I'm actually from academia. So my background is I was researcher in economics for a couple of years at universities in Europe, Australia, Singapore, and then I came to industry. I switched to industry. I worked for a couple of years in industry. I always stayed um, connected with universities and academia, and then I was lucky to climb up the ranks a little bit. Now working for H2O as head of SME customer success, where I'm focusing on value creation for our customers. So that's my big goal. I mean, everybody's trying to do that, but I'm still connected with academia. I'm still adjunct faculty, work for University of Connecticut in the math department. Really lucky to do that, and I work for business schools in Europe. And so always stayed connected with academia. So that's my background. That's where I'm coming from. I have PhD in economics and master's in master level in business administration. And so I'm not really from the computer field, but I definitely have a deep statistics background, analytics background. I was leading data science departments before. So it's I think that's just summarizing why I'm talking about the topic. And I would like to um, give you a little bit of a background to where we are right now in the state of advanced analytics and academia, how we switched, and I'm going to switch a little bit to industry. And then I want to talk about the challenges that arise in industry and how actually academia is not connected to that. And I would love to discuss that with the people. Do you have any questions before we get started?
No, all good.
Okay, so again, it's a discussion, right? And I would like to, I'm gonna talk for 15, 20 minutes and then just to give you the background and the challenges, and I would like to have your feedback on it as well. Especially as your practitioners as well. So give you a little bit of a background of the state of the art in advanced analytics. Over the last years, let's say the last 7 years, and I found a nice study from Stanford University, which really summarizes the state of the art in AI and especially in academia. And I really like that to see that the field of advanced analytics, they call it AI, but AI in the biggest definition, in the broadest definition, in a way where we fall in machine learning, artificial intelligence, robotics, vision, all those pieces are part of that. I usually call it advanced analytics or AI. That doesn't really matter. So what we see is that universities really react to the and offer more um, classes and courses in the field of AI, and that's what you can see here. Like over the last 6 years, and then the numbers are already 2 years old, but they like doubled. So the universities definitely offer. We don't see it just at the university level. We see it at Coursera. We see it at others. There's a lot of education areas where you can go deeper in the field, and you can also see that the demand is increasing. So you see that more and more students, that's just the introductory course for artificial intelligence, but it really jumped in the over the last 6, 7, 8 years. So we see that there's a huge demand that we're trying to fill. Very interesting is when we look at the geographic differentiation, and we always, and I come, I originally from Germany, so I come from Europe, and there's where I came to the US and I thought, okay, good, the US is so far ahead, and that's where we can also see is that demand currently in Europe is has a way higher growth rate than it is in the US. We see a slight peak in the 2018-19 years, and it goes slowly down. That might also be because this is like the introduction of AI. I think that's the reason is that we are slightly shifted between different geographic regions. So we are in the maturity curve a little bit ahead here in the US. That's why we see a slight decrease in the demand. But what we can also see, and I think that's an important next step, is that how it breaks down. So what we're doing here is, and I would love to ask you when you look at that, what do you see when you see how, and that's PhD programs, especially because it's easier to track, but how do those break down? What do you see right away?
I was curious why computer science, but not mathematics or statistics or economy.
Perfect. And that I know we are connected, Bing Wei, but that's exactly what I see too. So what I see in the US, and that's why I'm working with University of Connecticut, is like what you do is like you have this all the STEM areas, and the STEMs don't break. So you see that when we see specializations, we see these specializations within STEM. Very interesting that when we look about how it breaks down, and as the next, let's say, maturity step of the AI space, we just saw that Europe is at the beginning, US goes to the next level, and we break it down. We don't break it down in economics or in computer science and finance, computer science and something. We break it down within the STEM areas. So what that actually means is, and that's what we can see, I just took the curriculum from Stanford, statistics, data science curriculum. When you go through mathematical and statistical foundations, experimentations, science of computing, you don't see any breakout in other areas, social sciences, or how to apply it to economics, or how to apply it in other areas. It could be an elective course, but it's not part of the education. Just to keep that in mind, we're going to talk about it at the next stage. But what we can also see is that the big, and there's a big the big, I don't know how to say that. It's kind of confusing that you have so many people going, and that's PhDs in AI and robotics. They're going into sorry, here. They're focusing way more on academia than industry than they're doing in academia. So you see that more people going to industry than they're going to academia. I mean, one of the reasons the salaries are higher. Good. Okay. Check number one. But when you go to industry, and why is there no academic program that prepares them for the challenges in industry? So, and the challenges are here very STEM focused, as we just looked at. So now we make the step to industry. Let's go back and think about the industry side. So we put this on one side. Now we look at the industry part. And the industry part is equally interesting because it, in a funny way, it lines up with that. So we see that the investment goes up. Cool. That's why we have demand. That's why we have people moving from academia to industry. That's why we have less people in faculties and we have more people coming to industry because the demand is higher, salaries are higher. Good. That totally makes sense. But when you go and there's huge expectations in that field. Funny that when you talk about the organizations that invest in AI, they see, yeah. Does anybody want to say something? It's a discussion.
No.
Please feel free to ask questions.
No. But I do, since you stopped, I was going to ask, are you going to do some experiment on your students now?
I'm not
To
answering
prepare
that
them for
question.
industry.
Yes,
Right?
that's the goal. So, but
Yeah.
what I'm doing is really, in every teaching I'm doing, it's a real world preparation. So my job is really not to give them a textbook, right? And I can recommend 50 textbooks. I think people when they are 18 and older are able to read. So and that's not what I'm doing. So what I'm trying to do is really prepare my students for real world experience. And this
Mhm.
has mostly not really much to do with what you learn in academia. It academia is pieces to it, and they're important, but there's huge differences, right? And we're gonna get to that. We're gonna talk about it in detail, and I give you examples, right? So, but what we can see, the demand is really not driven by, hey, we want to do fancy stuff. You can call it fear of missing out, FOMO. That was one of the reasons. But now the industry is maturing in a way that there are expectations on revenue, right? So how do you make money with that, right? And when you really think about it, there's a lot of organizations, a lot of pieces where we bring that in, but the the expectations are way higher than what we're currently delivering. I'm going to get to that. But where we can see where we make right now, and that's very interesting, is where you see the investments going. You see everything goes up. Fine. Okay, good. But what you can see is like that whenever we break out of this original field of something, of AI, data science, whatever, and we find business applications, right? You see that the investment jumps right on it, right? You could, for example, see from 2019 to 2020. So we have autonomous vehicles, fleet, autonomous driving, road, whatever, all this stuff, is still is still a big hype and high interest, right? But then you see a little discovery, a little business application that shows how to actually apply AI, data science, computer science, whatever, in a specific field, you can see how immediately it gets picked up on the investment side. So 2019, you have to 2020, you have, I don't know, 5 times more investment in the drugs, cancer, molecular and drug discovery, because that's where we showed big value, right? You can also see the speech recognition, computer interaction, etc. That was the years when we had the big NLP and models and the big steps where we really moved forward, where business applications immediately came out of it. You can see how immediately it gets soaked up from the market, right? You see that with games and gaming and football. That that's what I want to show is like that there's a high demand, but we're not actually delivering it right now. We're not doing it in academia, right? So we are very focused on that STEM part, right? But what you can also see is that that's another way of seeing how that market is is maturing, right? So you can see that the investment reached the job posting reached a height in 2019. Yeah, then we had COVID and so on, but it is at a level where we're now looking for answers, right? We're not investing just because it's called AI anymore, right? We want to have an answer on questions in our life, and we barely get that. Like there's a gap between academia and industry, right? Here you also see like, yes, of course, when we talk about job postings, right? You see information, you see professional science tech services. Okay, cool. Those are the percentage job postings on the overall industry. But then you see things that are very strange, like agricultural, forestry, and fishing, right? So somebody came up with an application there, and it immediately gets soaked up. It immediately gets applied. So if we would start thinking from a different perspective, we could definitely help more in this field to drive growth in that field. That's what I want to say. And when we go now one step further, it becomes even more clear. So I know that slide I showed many many times every year, but it is still as let's say up to date as it was 2 years ago. And that's when you look at how many organizations drive value with AI, right? So we have a lot of organizations that invest a lot of money in the field of AI, data science, and so on. But it's really hard to create value with it. And this goes back to exactly the problem what we just talked about. And I show you why. And then Forbes just titled that the problem is not the technology anymore, it's the understanding how to make money with it, how to create value with it. And money is just one way of doing it, but in general, money. So when we talk about value creation, right? And I make a very simple formula, right? And this formula is everybody usually agrees to it, right? Say, okay, yeah, you need business understanding, yeah, you need analytics, you need data, AI and data science need data, right? You need to transform the people and the organizations, and you need the right technology. So those are usually the 5 pieces everybody agrees to, right? The problem with that is in our education, as well as in our organizations, we don't really merge those things. We don't bring them together. We have a education for MBAs, economics, business. And I would even say economics is a mix between business and analytics. Because you have econometrics in it and more statistics, right? So you have like the business, and then you have your analytics field, right? So we just talked about statistics, data science, that mathematics. Those were the things that we just had on the Stanford example, right? And then you have the whole field of data, right? When we talk about data, we're going to talk about it in detail in a second. But yeah, everybody agrees you need data. And then we have data management. Bing Wei can sing a song about it, right? Then you have the whole piece of transformation. You know, people are, and we talk about that. People, you need to convince people to work with it, right? Not everybody is open to work with AI, and a lot of people have misconceptions of what AI actually is. And then you have the last piece is the technology, and yeah, we have programmers, and we have the technology, we have the cloud conference, so we have the hardware and the baseline for that. The fun part is that everybody thinks that if you hire 5 different people that are experts in those fields, that thing should work. But that's not the case. And the problem here is that the relationship is not additive. It doesn't really help if I hire a business guy, an analytics guy, and a data guy, and don't have transformation and technology, because the expectation is then I create a little bit value. The problem is it's always zero. Why is it always zero? Because the relationship is multiplicative. It's an interactive relationship. All of those pieces interact with each other. If I don't have data, the value is going to be zero. I can build something great and it's not connected to a business opportunity. The value is going to be zero. I can have something amazing and nobody wants to work with me because I'm going to get everybody fired because the solution is so great that I fire 1,000 people. They don't want to apply it, and I don't have any idea about technology. Then all the rest is not working either. So, but what is important is to have this overlap of them. But we don't have that in education as much as we have silos in corporate where we don't get those overlaps. So, and I usually talk about this because with a specific framework, because when people talk about challenges of AI, they talk about the challenges in their fields, and those are pretty simple. The known nodes. So you have the knowledge, you have the awareness. We talk about analytics and accuracy. We talk about data and availability. We talk about technology and scalability. We talk about those are all the challenges in the specific areas. And then you have a handful of known unknowns, right? Those are things you might be aware of, but you don't give it the prioritization it requires because you don't see how it applies. That might be responsible AI because you have never gotten sued because you did something wrong with your models. After the first time you get inspected and a lawsuit is coming, then organizations start react. You don't have a transformation understanding or understanding how the pieces connect with each other, but you don't think that's important. but you learn it is. And this is actually the big unknown that organizations learn over time, and it takes them, right now it's estimated to have like 9 to 10 years for that AI journey to to uh, to learn from trial and error and to learn those unknowns. And I think that's something we need to change, because that should be part of our education. That shouldn't be part of a hard learning process for the organizations, right? And then they're gonna realize that that they can trust academia again, right? Why would I go and to academia to get the people if I can get people that are, that's like what Elon Musk said. You don't need a high degree. You need to be a good coder. That's enough for him, because you're just a puzzle piece. So you don't need to have a degree in computer science if you have all the background and then learn 20 years. Right. And I think that's something we need to go back to and reevaluate in our current education. And I want to give a couple of examples on that side, and want to help people to think about it, maybe from a different perspective. So first of all, do you have questions? Do you agree or say, no, that's totally not the case, and I have all this education and I got that from Harvard? So like might happen too.
Yeah, I think that applies to everything, right? So
Yeah.
we don't know. There are things we don't know. So, but this, yeah.
But I mean, yeah. So let's go one step further. So, and I want to give a couple of, I'm gonna throw things at you to show you how I like what I mean. I think the first person part is like business understanding, but it's not just the business understanding that's required, because then you're just a consultant, a management consultant, which is great. But it is the combination of how you create business with AI. And therefore, it is a deep understanding of opportunity creation that is required, and the understanding in analytics and business to understand the opportunity. Here, for example, Capital One. Capital One started 20 years ago as a data-driven company, very early with analytics, and they're more a technology company there now than their finance. And one of their products they have is like Eno. Eno is a very interesting, I would call, virtual assistant that helps you with your banking. And they were one of the first ones that actually developed that. So and that system is actually providing a tremendous extra value for beyond the financial product they had in the past. Other examples are self-driving car, like a Tesla, right? So yes, it's a car, good. Second, it's an electric car, good, check. That how you pay maybe $5,000 or $10,000, you would pay more for an electric car. But how much would you want to pay more for a self-driving one? And that's the thing what Tesla is building on. It is the price premium, the extra value creation that AI is promising, because they don't have it yet, for the future. So in order to do that, in order to understand those pieces, whenever somebody comes up with it, you say, okay, but that's obvious. Isn't that obvious? Self-driving car? Of course, I would love to have a self-driving car. And then, of course, I would like to have an app that tells me if there's fraud on my bank account. And I would love, and as soon as or like Alexa, Echo, yes, of course, I would love to have something that, is talking to me. And I buy a speaker that's sitting in my living room and in my bedroom and listening to everything I'm doing. So, but from that perspective, afterwards, everything, and looking at a success from afterwards, it's always easy. But how do you come up with that? So how do you have that domain and business understanding? That's one thing, but we don't teach it. Then, even if we have two different people, it's important to understand the overlap of business and AI analytics and how AI creates value. So what are the value creation types that AI is providing, right? And this changes over time, right? But what are those? So, and when we go and ask a data scientist, how does AI create value? They start with, okay, with supervised or unsupervised learning, has nothing to do with value creation, right? And then what are the challenges behind it? So one thing is the opportunity, that's one side, but then you have, and that's the next part, is you have feasibility and transformation challenges. And let's talk about those. Let's talk about feasibility. When you go to a data scientist and ask what the data scientist goal is high accuracy. Building an accurate model by feature engineering, all those things, which is right. It's a basic requirement. But when you think about it, for example, from Siri got introduced 2014, right? Big hype. Everybody bought this phone because of Siri. And they introduced it, and that is a huge, I think, like it is very descriptive of the problem. The I guess it was an executive leader in the marketing field introduced it as your virtual partner, somebody you can talk to like you talk to a best friend, to your assistant, to something else. And you introduced by a couple of examples, doing am I gonna need an umbrella tomorrow? Their favorite example, First of all, I never talk like that. I never go to my wife and say, do I need an umbrella tomorrow? I always ask, gonna rain, So but in this case, what they did was creating something that did not fit to real life application. And what they also did wrong was they created expectations that were not, the product wasn't able to fulfill. So how can we change that? Because like 5 years later, Alexa and Echo had, like, right now they're in 60% of the households in the US. Everybody has a speaker, right? But going back to Siri, how many times do you actually still use it? Do you use Siri? I barely do, because it doesn't apply to my day-to-day way of working. So, and Siri is not fulfilling the expectations it created. But this is an extreme example. But when you think back in the analytics space, in our day-to-day jobs as data scientists, we have the same problem, right? So you go to business and they tell you, I want to increase sales. Okay, cool, we can do that. So what do you need to do? Or are we gonna predict sales? But it's not. People have something totally different in mind. You think about, you predict sales, but actually you want to drive sales. That's totally different things. I was in conversations where business was talking about, okay, we would like to leverage AI and analytics, and we'd like to have a recommendation on what to do and how to do things. And the data scientists heard, I need to build a recommendation engine. Had nothing to do what the business actually had in mind. And then there was a big mismatch between what could be done and how it's done and what the product finally would be and what business would expect. And that's like where we need to know more about the algorithms and how we can actually explain them from a non-mathematical perspective, but also from understanding real life limitations, right? So it's not about, my favorite example is like in the churn space, insurance churn, right? And I worked not just for Aetna and CVS, I work for a lot of organizations in the insurance space, and everybody wants to do this churn, the churn example where you know predict people that are going to leave the organization, customers that are going to cancel their contracts, and you want to keep them, right? The interesting part is, although we are 85 to 95% accurate in predicting it, it's very hard to keep them. So it has nothing to do with the prediction itself. That's not the magical wand. It's about the actions you can take in order to keep them, and that's a totally different story. So, and that's where we then also need to be keep it simple, keep it honest, keep it to a level that can actually everybody understand, right? One thing we also like to talk about is like data, right? And when you bring up data in the data science space, it's usually okay, yeah. We have a lot of data. Okay, cool. So we have all the data we need. How do you know? So when I ask people, okay, what's the meaning of data? What's the value of data? I usually don't get an answer. Because there's no data understanding. There's understanding of the statistics of data, of distributions, the characteristics, accessibility, missings, all those things. But how about the meaning? So what data do you actually need? And it's very rare that I get an answer on that, because there's barely any understanding of the meaning and of data and the value of data. So usually it's like you have the discussion between data science and business, and one says, okay, what data do you need? And the other one says, what data do you have? And then you have the chicken and the egg problem, right? And that's one of the reasons why there's not a lot of organizations that can actually report that they're data driven. So we have a very low data literacy level in the organizations as well as at universities, right? So I had to learn it because my background is in behavioral economics. So I was working in market research. So I had to write my questions I want to ask people to get the data I need in order to make assumptions about whatever. So that is data meaning, but we don't teach that. We don't teach that in STEM. So that's why it's so important to learn asking the right questions. Why and how? Why is that the case? Why is somebody buying your product? You know, you can't build a model about sales if you don't understand why a customer is buying your product, because it's based on price, quality, all the stuff, and competition and all the other stuff. So how can you build a model on sales prediction, which you still do, building an ARIMA model, without understanding the pieces? Because the next question that's going to come after the sales prediction is, okay, good, everything you predict is going down. How can we change that? The answer is, I don't know. That wasn't the question. You just want to predict it. But that was implicitly the question, you know? So that's why we need to start thinking outside of the boxes we currently are, of this narrow way of looking at it, and getting out of it. We need to have a different perspective. We also need to learn how to interpret data, which we don't usually do, because
I think there is always efforts need to be made to make the data more meaningful, right? Meaning it really depends on who's actually looking at data, right? Now, for example, a data scientist looks at the data in a different way than the CXOs of the world, right? Because you need to still make the data more meaningful to their understanding format. I think that's where the whole interpretation is going out of flow, right?
Yeah, that's right. But we need to learn how to do that.
Yeah.
So, and that's like, if I work with somebody in business, I need to understand the business, not just the business problem, but how data is connected to it. And that's something we don't teach. Another thing we don't teach is that people are scared. You build a solution nobody wants to work with for whatever reasons. So usually it's out of the comfort zone. People have to change how they're doing things, and people are scared that they're going to get replaced, because that's what people think about AI. That's why it's so hard to scale AI in organizations, and that's why it's so important. And that's what successful organizations do in that space. They work with their end stakeholders that actually need to use the tool. They need to create trust. They need to create, and how it fits into their life. And that's something we also don't teach. And the last thing, and we need to learn how to build relationships, and how to, and that's like, when we make this very narrow, the education space, we miss all those pieces here, right? And the last space, and that's like something we're all good at, because that's what we all usually work on, is like the technology enablement. And there's also like a challenge behind that, it's not just the accessibility to the technology, it is the implementation of the technology. You kind of need to understand the beginning to the end. And that's something we also don't learn. When you go in the STEM field, you are and breaking that down in all those different areas, you learn pieces of that, right? And you learn, yes, you should go from data acquisition from ETL to the consumption of the data, but that's something we don't do. We usually learn only a piece of it, usually the piece in the middle. And as soon as, and then what we also do, we generalize things. We talk about it in a big space, A, B, C, D, and now let's focus on B. But we never talk about how to connect those pieces. We never talk about the details. And when you see and that people do it, and they have to do it the first time from the beginning to the end, they realize all the challenges that are actually coming. And that's something I also, we don't really do. Let the students do it themselves. Like when I teach, and I teach consumer, I teach applied psychology, consumer psychology. I let students, I don't teach a curriculum and say, okay, good, there's an exam. Students have to do a whole project on it, like from the beginning to the end, and they're gonna fail in it. They're gonna fail at different steps, and then I pick them up, and they have to understand why they failed, and they have to go again and again and again, because that's how they learn, right? And that's something we also don't do. And I want to give an example on the data space, like getting out of this box, thinking out of the box. And that's one of my favorite examples. I don't know if you're aware of it or if you've seen it. So there's a nice story around where in the World War II, when in the UK, when the planes came back from the battlefield, right? And they looked at the planes and saw all the holes in the planes. And then they said, okay, cool. Let's try to strengthen those pieces where they have holes that our planes don't get, shut down. And it was a mathematician that started to think outside of the box and said, that's the wrong way of thinking. So those are the planes that actually came back. So now think about the data. Every point is just a data point. The value is 0. The knowledge is that there's different areas that are, impacted. The understanding and the wisdom tells you more. And that's where we need to break out. It's not about, okay, cool. Now we predict sales, or now I strengthen those pieces in order for the planes to get shut down. The interpretation and the understanding of it is the other way around, that they came back because they didn't get shot at those other spots. So you need to strengthen the other parts, not where you have the holes. And I think that's a great example of, the looking from a different angle and a different perspective, thinking about the interpretation and the problem first before, making assumptions and, going that path. Okay, cool. That is it. That's what I wanted to show. But now I'm happy to discuss.
The last was excellent. The World War II example was really good.
Thank you.
Are you still a
but-
professor at UConn?
Hmm?
Do you still teach at UConn?
Yeah, I did this year a couple of small sessions, and then next year I want to teach a little bit more.
Can you hear me well from here?
Hmm?
Can you hear me well from here? It doesn't sound.
Yeah. No,
Yeah,
it's all,
Oh, okay.
it's only the computer's audio, maybe.
Oh, is it?
yeah, no, it's all good. I can hear you. It's all good.
Oh,
So
okay.
I
I was curious on your perspective on how research labs are run, because I went to UConn actually. I graduated about 5 years ago.
Oh,
I did a bachelor's in CS, but I worked in a research lab in the biology department, a microbiology research lab down in Beach Hall, if you've ever been on campus. I don't
I've
know.
actually never been there in person.
No? Oh, okay. Okay.
No, it's like,
Yeah.
I only had a couple of virtual sessions, and next year I want to teach in the spring semester. I need to come up with a clear
Yeah.
plan, but it's gonna be something like that where we
Yeah,
talk
yeah.
about, okay, that how to apply it to real world, and what do you really have to expect, and how do you
Yeah.
prepare for the job
But
you
in
gotta
terms of, I want to get your opinion on, like, do you think like research labs are running the correct way? So when I was there, I worked in a research lab, in a microbiology research lab. And, some of the professors that ran the lab, they own like their own genetics companies, or they worked at, if you know Jackson Laboratory, that company, they do like a lot of genetic research in like New England, and they work with, I think Pfizer. But when you're in the research lab, it's kind of run like a really crappy, low budget startup company. Like, you'll have grad students that are working on their thesis. They'll like lob you like a 20-page research paper and like an Excel spreadsheet. And they're like, hey, yeah, I need you to just like implement some of the methods from this and send me the spreadsheet back. And, that was like my take on like what academia was like beyond, the bachelor's level. It was like, it's really weird. Like each research lab was run independent. There was like no process for anything. And it felt like a 5-man startup company out of like a garage. Do you think that's kind of like how research labs are always run, or the way to go with it?
It depends. So
Mhm.
it's like they're going through a maturity phase as well.
Yeah.
And if you get bigger funding, you get to hire more people, you get more professionals. So it really depends on, if you have a $500,000 funding, then, you run it like that, or $100,000. Usually getting a $500,000 funding and some, that's already good. So, and then the next part is, do they work there full time, or do it's just like, do you patch it together? So it's like it really depends. So it's hard to say. And which one is better than the other? Also hard, right? So you have definitely like big organization, a big Stanford, MIT, and others that where you have like labs coming out of that. They're breaking out, they get big funding from big investors. They run different, right? And
Yeah.
then do they necessarily always create value? I don't know. But it's
Yeah,
not
that's-
it's not necessarily the labs that I'm after. The labs are usually already have a purpose, right? So
Yeah.
they're trying to focus on something, and they have an application. And they are always like a little puzzle piece, right?
Mhm.
But when you go and think about the education you get, right? How can you make this? And that's the way you're doing it, right? You want to be prepared for industry,
Mhm.
right? But the professors usually don't get, they get paid for teaching, yes, but they become famous because they're focusing, right? They focus on a very specific area in math, or a problem in, you have the professor that's in computer science and famous for his, whatever network analysis and something, writes 10 books about it and 50 different papers, and
Mhm.
but the application of it is then missing, right? And that's when I think back and to my and it was like undergrad. um when I think about my statistics classes, I had all distributions and skewness and all that stuff, right? After it, I forgot it all, because there was no real life application for me. I was just learning it to do it, but there was nothing. Why actually am I doing that? And how does it apply to real life? And how do you use it? Nobody ever told me. And that's like where we're still there, you know. Haven't made any step forward. And that's 20 years ago. It's not like, okay, it's, we made any step in a we're still stuck. I
Yeah.
feel. You can tell me that I'm wrong, but
I heard UConn specifically did like a little bit since I left. Like they're trying to do it apparently. So like 5 years ago they had computer science, and then computer science engineering, and then computer engineering or whatever. And it was like you could lean towards electrical, then there was a mix between theoretical and electrical, and then there's like purely theory. And then like 2 years after I graduated, they got rid of the computer science degree. Well, they didn't get rid of it, but they forked it into like 5 sub degrees. So like you can specialize in like cybersecurity or bioinformatics. And then like the guy that runs the bioinformatics lab works at Jack's labs, and then he runs the classes for that. So like they're like trying to go in that direction, I think. But that's just like one university, you know.
But that's just the maturity we have done in the past. We break it up and we break open the AI space in very narrow,
Yeah.
really technical specializations, but not applied specializations, right? And I don't speak for UConn specifically. I really mean in general. So UConn does a lot, and I know that universities are looking at it, but it's like
Still a long way to go.
still a long way to go, I think. And that's
Just
why I would.
on your question, right? You were telling about, a lot of, AI methodologies doesn't actually understand the business rules or, the actual expectations. They kind of, go a little more, so always there is a tendency or a difference between, what the actual model does versus, the business acumen. That's why business architects still, or business analysts still, show their presence, right? But the question is, how do you think that, is there any research done to basically narrow with the small investments? Because that looks like, total of a human acumen versus, what is actually built in the system. A lot of things cannot be translated, right? So what is research saying in that area specifically, right? Well, I know a lot of companies are trying to bridge the gap by actually bringing in a lot of accelerators to make sure the data is very close to the business understanding. So what is your perspective? Any thoughts on that?
I think the biggest problem is that we are still stuck in the past. Everybody of us. So I'm in business, and I'm an economist. I'm in my behavioral patterns I learned. You go to a mathematician, and the mathematician's talking to you, and they're describing things in a formula. It doesn't resonate with me at all. Not that I wouldn't understand it, maybe, but I think different because I learned it different. I'm a different person. So I guess something we need to start, and that's like, I think that's the next step, is, or should be the next step, to understand all the different pieces, and they have a different mental mindset to it, right? So if you go in an organization, and I really like to look at that, because they are kind of like collections of different, when you think about those 5 pieces, right? Technology, data, whatever. So organizations have specializations in different pieces of it. Some are more specialized in data, some are more in technology, some are more in business pieces. And when you talk to them, you see how the story changes, and how, the priorities change. And but all of them struggle to create value, because they don't bring them all together, right? Because again, they're focusing on one or two. They don't focus on the big picture, and the big picture is still missing. You know what I want to say?
Maybe somebody will come as business as a service, right?
Yes. Yeah, that, I mean, that, Salesforce.
That's a very different view. The other thing that I was, you remember you were telling about the Siri example, right? So I think it's basically from how simplified you can actually tell a offering or a story. For example, like say I've been into one of the AWS conference where they say, okay, I've actually put an AI model. This is basically a lot of consumer produce, right? Where I actually build a model to basically talk about the soil texture, the weather conditions, the water table, the groundwater table level, and then, the nature of the crop. Now, this is the perfect time for you to basically sow it, etc. Right? So now there's a lot of models to basically, improve, the whole thing. But these are all a large scale thingy, right? Now, how does that, how common man can actually get it, right? Now it comes to Siri, right?
Think about the farmer. Does the farmer go on Amazon, take the tutorial, builds it out?
I mean, how do you think a farmer in Africa is going to basically, okay, large scale produce is fine, right? So you told about Siri invention. Now the question is, I made it so much, I productionized so much. I want to attract a lot of people to make it commercialize elements to it. Now, what is the actually how many people use Siri? For example, it's really beneficial for somebody like, okay, I'm blind, I cannot basically see anything. So yeah, maybe I need some kind of a service. Agreed. But beyond that, right? Because there's a lot of commercialization element into it. That's the reason,
I think there's a great example, and that's called Calendly or Calendly. Are you familiar with that? So It's a very simple service. You go on a website, you connect your Outlook calendar in the background, and you provide a form where people can book time in your calendar. And I think that's one of the most brilliant service solutions ever built. It is so simple, and it fits into a problem which is huge. And it docks onto a standardized approach on technology, data. It fits into people's working processes and the way how they live. So finding that puzzle piece is brilliant. And he's a billionaire that built that, right? With a couple $100,000, by the way. There's a great story behind that. But what I want to say is, like, we need to start thinking from that perspective, right? Really looking from outside the perspective, looking at the holes of the plane, not by, okay, those are holes, we put something on it because we try to fix the holes. That's not it. You need to go a step back and think about, okay, a plane flying, getting shot, a plane, what's the problem actually? So, and that's so hard because we learned fix a hole. That's what we learned. We learned to fix a hole. That's what we wanted to do. But that wasn't the problem. And that's where we need to, hey, Shabar, that's what we need to start rethinking, right? From the perspective, and then need to think about, okay, how can we fix that? Hey, Jesse. And I think that that's the important part. How can we go one step back and start from what it's supposed to do, and not from those are the what I know and that's how I fix it, right? Or you again with the recommendation engine, right? Somebody uses the word recommendation, you say, okay, I need to build a recommendation engine. That wasn't even the problem, and that's where we are way too in our narrow patterns of behavior today, where we say, okay, good. He mentioned X, I need to build Y because that's what I connect, but I don't actually think about X.
Yeah.
Right. Cool. I give over to Vinod. Thank you so much. Really appreciate it. Great discussion. Love it. Thanks, Big Mike. Thanks for the invite. Always enjoy it.
Thank you.
Bye, Michael.
Hi, Michael.
Uh,
My mind is like messing up forward. So gross. Yeah. It's just regular water that just takes.
So are we not allowed to watch it on Zoom because it wasn't popping up on my computer when I was, it wasn't working at all, no. None of it said the breakouts were created, but they weren't like open.
that is the biggest problem this time. It's like